to all that are watching this. This is going to be notes for 5.3. First time that I'm doing this for this class, so we'll see how this goes. But again, this is notes for 5.3. You are going to need your calculator, so if you don't have your calculator, please make sure that you get one. And let's go and get going. We're going to be working with graphs of square roots and cube roots, and we will need a graphing calculator for it. So again, if you don't have one, please make sure you get one. And this is a graph of the square root. So again, I usually bypass the ones that they have. The square root graph usually starts at 0, 0, and then it's a swimmer arm. So it starts at 0, 0, and then just goes up. And then again, this is the square root graph. And then we have another graph here that you should know, which is y equals the cube root of x. And the cube root of x is kind of the swimmer arm here, but then there's an arm back there as well. So this is a cube root of x. The point that you want to make sure you're aware of is that it will all pass through. Excuse me, sorry. That's disgusting. It will go through 0, 0 as well. Okay, the domain for the purple graph is all real numbers. So the domain for the purple graph is all reals. The range is going to also be all reals because there's no limit. This graph keeps having y values that go down. Same with the y values on the right that y values keep going up. There is no interruption in the graph at all. Here, though, for the graph and the square root graph, the domain is slightly different. We start at 0. So again, that fancy way is start at 0. And we end at infinity. And the range is, again, we start at the y value of 0, and we go to infinity as well. I'm going to give you guys a different way to do that in this video on identifying the domain and range. But for right now, let's go and move on to a problem. So let's do 1/4 root x. What I would recommend first is let's get our calculators out and graph this first. So graph 1/4 root x in your y equals. When you do that, let's get rid of this. When you do that, you're going to go ahead and do parentheses for the 1/4, and then do a square root of x. E square root of x. X. Okay, enter. And now let's graph. And this is kind of not the window I'm used to, so I'm going to go ahead and just do a zoom standard. Zoom in number 6, because zoom 6 is standard. And that's what the graph looks like. It's kind of low. The reason it's low is because of the 1/4. What I can do now is I can go to the table. The table is second graph. And I can find some values that I can plot. So I can plot 0, 0 here. So 0 and 0 I can plot. So let's plot 0, 0. Let's see what else we can plot here. I can plot 1 and 0.25. So like kind of halfway up. I think I saw I could plot 4 and 0.5. All right, so that was 4, 0.5. And this was 1, half. I'm sorry, 1, 1/4. And again, the graph just is this arm like that. Now it says the domain and range. Here's how I'm going to tell you to do the domain and range. I think this is the first time we're going to do this in this class. First of all, that point is 0, 0. The arrow, well, we don't know what value that is here, so I'm going to put a coordinate here. And I'm going to say, remember that in this direction is positive, and in that direction is positive. Positive infinity and positive infinity. So the coordinate here is going to be positive infinity because x goes on forever in the positive direction. And the y value is positive infinity as well because the x goes on forever in the y direction. So my domain is going to be the following. So let's do domain in purple. The domain is going to be the x values, is smallest x value to largest x value. So small to large. So large x and small x. The small x value, now I'm going to be looking at these two values. So I have 0, 0, and I have infinity. Those are the ends of my graph. And the smaller value is 0. So the smallest value will be 0 here. And the largest value will be my red infinity. That's highlighted. Now, the way I know the brackets or parentheses, brackets are when there's an actual point. Parentheses are when there's not an actual point. Okay, so there is an actual point at 0, so we'll put a bracket there. There is no actual point at infinity, so we'll put parentheses there. Okay, and then let's do the same thing for range. Let's see here. So for range, and again, I will need to look at my graph for this. For the range, we're going to do, again, it's kind of the same setup. We'll do small y and large y. And please remember that this is something you probably want to put on your note card. Okay, so small y is and large y. Let's look at the y values and let's go ahead and take the smallest and the largest of it. The small y value is 0 of those two, and the large y value is infinity of those two. Okay, and it's exactly the same as the domain because there is a point at 0, so we'll do brackets, and there's no point at infinity, so we'll have that. That's my domain and range. Now, when the domain and range will change is when the graph gets moved to the left or to the right, so we'll have to be careful with that. Let's do -3 times the cube root of x. So let's go back to our calculator and graph this. Actually, I'm going to change this first. I'm going to do x -3 times x to the 1/3. That way I can enter my calculator nice and easily. So let's go here. Let's clear this out. And let's type in -3 times 2 to the 1 to it. I need to put in parentheses here. I think this should be fine. All right. Yep, that looks like the graph that I want. So it's kind of like two swimmer's arms there. And let's go to the table so we can plot some values. Okay, it looks like I plot -1, 3, so let's plot that. -1, 3. And then let's plot 0, 0. And let's plot 1, -3. And hopefully you saw how that was. The graph kind of starts up here like a swimmer arm and then drops and then kind of goes like that, like an S, a backwards S. So that's the graph of it. I'm going to put some points here like -1, 3. I'll put a point here like 0, 0, and I'll put a point here like 1, 3. And I'll do the ends. So at the ends, I want my coordinates. Remember, this is a negative direction, a positive direction, and a positive direction, and a negative direction. So let's look at the y value and x value for the ends. So the ends here, well, this is in a negative direction, and it doesn't stop. So that's a negative infinity. The y value is up there, and it doesn't stop, so that's a positive infinity. Down here, we have a positive infinity for the x's because it's in a positive direction for x's. The y values are a negative direction and they don't stop, so that's a negative infinity. Now, you didn't have to necessarily do that part because the domain and range for a cubic graph for an x to the 1/3 graph is always negative infinity to infinity. But I did want you to practice this a little bit more though. So I think we'll be able to do that in the last one, and if we don't, we'll be able to do it in class for sure. So there's your domain and range. And now next. So that's all for that one. Okay, so 3 and 4. Now we have to graph it and describe the transformation. And I think for both of these, I'm going to also do a domain and range as well. So let's go and do A. G of x equals root x minus 3 plus 4. Let's describe what's going on here first. This minus 3 moves the graph right, so it moves right 3. The plus 4 moves it up 4. Remember we start at 0, 0? So if we go right 3 and up 4, we should expect the graph to start here now at 3, 4. And it's going to grow something like this. But we'll graph it to see what it actually looks like. So let's go to y equals, and let's do root x minus 3 and plus 4 and see what the graph looks like. Hopefully we're right. Oh, yes, it does move right 3 and up 4. Let's go to the table to get another value so we can graph it more accurately. And it looks like 4, 5 is another point. Okay, so let's just make sure we, oh, I kind of did that already. Excellent. So 4, 5 is here. I just want to do the domain here for you so you can see the difference when the graph is graph is moved around. So here was 1 point, and I'll put this in red for the ends. I get the ends of the graph for domain and range, so get ends for domain and range. This problem doesn't ask for it, but I just want to show you anyways. Get ends for D and R. Okay, so the end here was 3, 4. The end here, well, this looks like this graph ends at in both positive x and y, so a positive infinity and a positive infinity. So the domain for this graph is going to be, remember, small x value to largest x value. And the smallest x value and the largest x value are 3 and infinity. So we have 3, infinity. Now, I shouldn't have put parentheses here yet because this is an actual point at 3, so I have to use brackets, parentheses when the point doesn't actually exist. So let me change that here so it's nice and neat. And now let me do my range. Range is small y to large y. So the small y is going to be in this color here. We have 4 is a smaller number, infinity is a larger number, and we have 4, infinity. Okay, and for 4, infinity, infinity is not a point, so we put parentheses there. 4 is a point on the graph, so we're going to put a bracket here. And this is how we would do domain or range if a graph was translated. But again, please note, A does not actually ask us for that. All it asks us to do is describe. The description is right here. And it asks us to graph, and the graph is right there. So now let's go and finish up with B, and then that's it. Then you'll be able to start your homework, and thank you for watching. For B, let's go and do, actually, let's change this first of all to negative x to the 1/4 plus 2. All right, so let's go and do y equals. So one note while I'm typing this in is you might have noticed that anytime I have a root, it's easier for me to put this in a fractional exponent form. Now that's not always true based on the calculator I have, but for this calculator will work, and if you don't have this one, I can definitely help you and show you how it's supposed to. I never showed you the graph of x to the 1/4, but I think it looks just like root x. So it is just one little arm. Let's go and go to the table and see what's happening here. Actually, before I do that, let's describe it first since I was supposed to do that. This negative flips the graph, so flips across x-axis. And the plus 2 up 2. Okay, so flips across x-axis, flips over x, and up 2. So this does look like the graph that we kind of expected. It looks like the root graph, but it grows a little bit slower than it. If we go to the table, we get a value of 0, 2, and then we get a value of 1, 1 I saw in there. And the graph kind of just grows like that. All right. Yeah. Now let's see what else we have. And that's it. That's all I had to do for that problem, and thank you for watching.